Yeah.
Hey everyone, welcome to the next Math for the Impatient. I'm here with Stan Kladko, CTO of SKALE and co-founder. Let's jump right into it. Let's talk about running high-performance dapps on SKALE. What are some of the unique challenges that appear when you're running high-performance dapps?
First of all, I would like to say that it's really important for us to run applications that send lots and lots of transactions. And the entire purpose of SKALE network is to make large volume applications run on blockchain. So over the last 6 months, we've seen significant growth of the number of transactions on our network. And probably you guys know that pretty much every week we post how many transactions we had on our network. And these numbers keep on growing. But then what's happening is that people now realize that you can actually run many more transactions on SKALE, but also you can, any particular transaction can use much more computational power. So the applications that we've been running recently on our network are not even possible to run on other networks such as Ethereum mainnet, because they require lots and lots of computational power and, so to speak, eat lots of gas. Because of that, we have more and more people running more and more things. And just give you an example, Marcus. Last weekend, we had like some applications running something like 27,000 requests per second on our network. So we, at the moment, SKALE network is really loaded, and we want it to happen. But what also we now realize is that some of the things that work for low performance applications don't really work for high performance applications. And we are inventing and tuning and trying to understand how we can run more and more on our chains.
Very cool. Yeah. In fact, just as a side note, scale.space/stats. You can go to that right now if you want to check out and see what's going on the network. That takes me, kind of to the next question, which is, how does a dapp architecture change if you have a high performance dapp?
Yeah. So one thing which we realized recently was that if you have a high performance application, you need to separate read requests from transaction submission. Typically, if you have a low performance blockchain, the same nodes accept requests for a transaction, which are requests to change things, right? If you're sending money to someone, that's a transaction. But then there are lots of also read requests. Read means that someone retrieves information from the chain. For instance, someone wants to find out how much money a particular account holds, or someone wants to find out activity of a particular user. So on a low performance blockchain, both read requests and transactions go to the same nodes. And at some point, if you scale both, if you increase the number of transactions and also increase the number of read requests, they start to interfere. And what may happen ultimately is that you may end up issuing so many read requests that they will actually slow down block production and slow down transactions, because ultimately the nodes, the computational power is shared by read requests, by transactions. And if there are too many of one kind, the other kind is suffering. And so for the last couple of weeks, we've been trying to understand how do we solve this issue. And essentially, if you have a high performance application, you need to separate the types of requests, and some nodes need to only serve transaction submission, and some nodes only need to serve read requests. And so in our chain, there are 16 nodes, and these are core nodes. These are the nodes that handle block proposal, block submission, transaction processing, everything related to transactions. So if you want to actually also get lots of read requests, you need to issue those requests to other nodes. And luckily, we already have a node, something that we call a sync node or an archive node. This is a separate node anyone can run. And it's not part of the core chain, but it actually runs a replica and keeps on synchronizing this replica with the core chain. So what we've understood recently is that if an application needs to issue lots of read requests, the read requests will actually need to go to the archive node in order for them not to push too much the computational power of the core nodes. So for high performance applications, we are now separating things, and we're telling people that if they want to read information, they need to run either their own node or someone else can run an archive node for them, but it has to be a separate node. So one thing which is happening now on Scale network, and many applications already did this, is they're running their own archive nodes or sync nodes, and the read requests are going to those nodes. And this actually can significantly ease operation of the core nodes. So that's one thing. And another important thing is that we have something that we call Scale proxy. And Scale proxy is just a server that anyone can run. And it essentially load balances requests to your core nodes. So you have 16 core nodes, but if you don't want to care to which of the nodes you submit your transactions, you can also run a proxy, and this proxy will, essentially it's a load balancer that intelligently submits the transaction to the nodes that are least busy, and also does some kind of averaging. So every node gets pretty much the same share of requests or transactions on everything. So basically, the architecture does become a little bit more complex. So you run the core nodes, you run the proxy that load balances the transactions. The proxy also has another function. It also can provide protections against denial of service attacks. So if someone tries to do too many things on your chain just to kill the chain, the proxy can at some point say, okay, that's too much. I'm going to blacklist this particular user. So the proxy is also a denial of service protector. And then we have also these archive nodes and read and sync nodes. So the entire architecture does become a little bit more complex compared to what people are used to run. But that's kind of a necessary thing because we are now talking about running really high performance computations, running a full equivalent essentially of what people do on Web 2, full websites. So we do need people to understand a little bit more how things work and use the architecture that works. And that's pretty much what's happening on the network now. And hopefully during the next months, most of our dapps will do this transition and use more effective architecture for high performance blockchains.
Cool, awesome. So I mean, I think the last question, which is probably in everyone's mind, is what are the new features that Scale is going to implement, specifically with regards to handling and dealing with high performance dapps?
And that's an interesting question. What happened in the past, if you look at the Ethereum network, it's running at about 15 transactions per second. And also every particular transaction is not so much computationally powerful. Typically it just transfers money, just does a little bit more, but not so much. With Scale, every transaction can be much more powerful. It can do lots of mathematical computations, and also we have many more transactions. So what we're finding out is that when we started with many things that were normal in blockchain industry, but now we're actually going to be adding more features to take into account the fact that at the moment Scale network is way more loaded than other networks. As I told you, 27,000 requests per second. It's a pretty large number of requests, and we can only expect in the future that these requests will grow. So one thing which we are planning for release 2.2 to introduce something which is which is called caching. The current Ethereum mainnet doesn't have this kind of things like caches. A cache basically means that if someone asks you the same question repetitively many times, instead of computing the result every time, you can compute the result once and keep on shoveling back to the user the same result, and then you can update the result. But the update can happen maybe once in a second or once in 5 seconds. And then in this way, you can really offload operations and make it easier for the blockchain to cope with lots of requests. So one big thing for 2.2 is going to be introducing this caching. And with caching, we can hopefully go to many more requests, so from thousands to maybe tens of thousands, hundreds of thousands per second. So that does become now a big thing for us. How many requests we can serve per second, having that many of those requests are repetitive. And the reason why they're repetitive is because many of the client libraries, such as Web3.js, Web3.py, MetaMask, the guys that connect to blockchains, they actually, unfortunately, issue lots of totally equal repetitive requests because they're used to operating slow and they don't really care. So what we want to do on our side, if we do have so many repetitive requests, we're going to cache information and make it easier for us to cope with those requests. So the big feature that we decided to implement for release 2.2 is going to be this request caching. And then we're gonna look into other things such as speeding up EVM, Ethereum virtual machine. The version of the Ethereum virtual machine that people are running and we are running now is something which is called an interpreter. Basically, every time you get a request for information or you request to compute something, the virtual machine is actually interpreting the bytecode, interpreting the software and running it. But there's actually a way to run the software faster, something which is called compilation or just-in-time compilation. There are actually features of Ethereum virtual machine that allow just-in-time compilation, but they weren't used in the past because machines were so slow. So one additional thing that we are considering for release 2.2 is enabling this just-in-time compilation to make the Ethereum virtual machine faster. So basically, I think to make long story short, because we have so many requests now, because the applications are actually going into this high performance direction, many things that people didn't care in the past actually do become important, and performance really becomes really important. So there will be much more work in the future to make scale chains more performant. Having said that, at some point, you do need to have more chains. Even though we're trying to make every chain more performant and help our customers, if our customers become really successful, it's unavoidable that because every chain, no matter how much you optimize it, at some point can be full, can be computationally overpowered. So at some point you do need to move to architecture where you do use more chains. And we hope that some of our customers will be using them in 2023. Definitely, we do have some customers, as an example, Xorde. This is an application that does things like, for example, fake news checking and essentially crowdsourced validation of information. This type of applications can have theoretically millions of users. And while a single chain can serve thousands of users, and it's just a matter how much we optimize, how many thousands of users the chain can serve. If you're going to millions of users, you do need to have more chains. So it's interesting that we're essentially now getting to this point, something that we envisioned from the beginning, that we do have applications on scale that inevitably will have to go the multi-chain route next year because the computational requirements are getting so big.
Yeah, so multi-chain is not just a concept, it's an inevitability because it's the only way to actually get to billions of users.
And it's really funny because, I think, Marcus, we've been talking about this for a long time already, and it was a little bit theoretical. But what we're finding out is that these things were theoretical because for many years, dapps didn't really increase their computational power. They didn't really increase the number of users. And the industry was growing, but the number of transactions didn't grow. The number of users didn't grow. Now, with all of the crypto winter, but also with changing times, the times are changing in the blockchain industry. People are really hard pressed to get successful applications. And I think the year of 2000, there's been like a little bit of a cleanup in the year of 2022. But in the year of 2023, there will be new applications and new directions. And pretty much what we see that the only direction viable, if you want to have something where people really use it, and there are now 8 billion people in the world, you do need to have multiple chains. And I'm actually excited that, pretty much now we're seeing the beginning of this. It's still early, but we're seeing this the industry, the ship moving in a new direction now.
Awesome. So thanks very much. It's a little bit about some of the ideas that we have around running high-performance dapps on Scale. Please look below. You can subscribe to the channel, subscribe to us on Telegram. You can go to our Telegram channel. You can go to us on Twitter. You can go to us on Instagram even. And we're even talking about putting together a TikTok page. So that might be something you'll see coming soon too. Thanks very much, Stan. Appreciate it.
Okay.